A lamp, a voltmeter, an ammeter, and a battery with zero internal resistance are connected as shown in the schematic. Connecting another lamp in parallel with the first lamp, shown in this area, would do what? We're given 4 possible options, and essentially the options are, is it going to change the reading on the voltmeter, the ammeter, or do nothing? So taking a quick look at this circuit, we see that we've got a battery, and the circuit wraps all the way around to the lamp, goes through an ammeter. There's a voltmeter here that reads the voltage either across the battery or the lamp. It's the same. There's an ammeter here reading the current in the single loop circuit. And then there's a lamp here that will have some resistance. So, because there's a voltage, current, and resistance, we can describe this circuit using Ohm's law. V equals IR. And so in this question, we're asked, is V or I going to change when we add a lamp, which is going to change the resistance R? Well, we can probably eliminate this option, since adding a resistance will either increase or decrease this value, which has to change either the voltage or the current. So it won't be that first one where no change in either meter happens. So in adding another lamp, we're going to be changing the resistance. And since it's being added in parallel, we can look at the equation that describes adding resistances in parallel. 1 over RT equals 1 over, we'll say R1 is the lamp that was there. And then if we added the second lamp, we would have 1 over R2. Now what that's going to do in adding that 1 over R2 is it's going to make this number, whatever it was, it's going to make it bigger than it was before, right? This 1 over R2 contributes some positive number, so it's going to increase. So I'm just going to rewrite this as 1 over RT equals some increase, an up arrow, okay? There's an increase in the resistance, or the number on that right-hand side of the equation. And if we solve for RT by cross-multiplying, we get RT equals 1 divided by that increase. So how does that affect RT, the total resistance? Well, 1 divided by a number that's getting bigger is going to be a number that's getting smaller, right? If we have 1 over some number and that number increases, then what that's going to do is it's going to decrease RT. And we know this. If we add a resistor in parallel in a circuit, it decreases the total resistance. So coming back to our V equals IR equation, I'm just going to rewrite it a little bit bigger. V equals IR. We now know that the resistance is going to decrease. So what does that say about the rest of these two values? Well, the voltage on the battery isn't going to change, right? This battery has some voltage, but that's not going to change. The voltage of the battery isn't going to change by just adding a lamp. So it remains constant. So if V stays at some number and the resistance decreases, the current must increase for that equation to remain balanced. So looking at our options, we can select the increase the ammeter reading.